So for related rate problems, again, it's related to the chain rule. So if I want to find dy by dx, I can find dy by du, then intermediary, and then do du by dx. So most of these problems end up being a dy by dt, which then we have to do dy by dx, and then we have a dx by dt. Okay, so there's basically only a few different types that we really run into. The main ones are the snowball problem, or there's a sphere problem. And as we change the volume of the sphere, the radius changes. The ladder problem, the water in a cone problem, which is related to the piling of a sand. And so as we pile sand up, it's going to form a bigger and bigger cone. Okay, those two problems are essentially the same problem. The lamp shadow problem, so you have a person walking away or towards a lamp and the length of the shadow changes. Rotating to follow an object, so if we have a road, for example, the typical example is we have a road, a car is driving down the road, and an observer here, that's not a very good person, an observer has to turn to watch that car come past. Okay, so that's rotating to follow an object. And again, that's a typical type of problem. And then the oil spill problem, where the area of the oil spill increases, we want to know how the radius changes as we put more oil into that oil spill. And the distance between objects, and we did a car problem in the previous day. But these are essentially the same types of, these are essentially the few different types of problems we run into with related rates. So there's some tips for related rates. So first of all, we want to write an equation that connects the variables in question. Okay, so if we have a volume problem with radius, we want to have a question that relates to volume and radius. Okay, if we have distance, x's and y's, we want to have an equation that relates, the x and y positions to a distance. Usually that would be Pythagoras. So we often use Pythagoras. Okay, the properties we might use are Pythagoras, similar to triangles, some trig, formula for area, volume, etc. Okay, once we've done that, we want to differentiate with respect to time, because usually the rate is with respect to time. So we want to use chain rule. And then once we've done that, we want to substitute known quantities and solve for the unknown quantities. And again, we want to keep track of direction, whether we're filling something or draining something out. Okay, if we're going left or right, we have to make sure we keep track of the plus and minuses as well.